Hello, and welcome back to the series on Anagame. Today, we will talk about the TrecPointer, Anagame's dedicated smart pointer. In a previous video, I talked about what smart pointers were for and briefly mentioned what TrecPointers were for. The idea for the current generation of TrecPointers was partially inspired by the standard shared pointers, as well as the Rust language and their RC pointers. I say Rust because one way that the language ensures memory safety is by greatly limiting what a Rust programmer can do with the language. While Anagame is a C++ project and I can't impose a limit upon C++ itself, I can use C++ features to impose limits on how the TrecPointer can be used. For instance, while you can create a shared pointer with a raw pointer, you can't do that with the TrecPointer. The reason for this limitation is that if you end up with two counters, you'll eventually be calling delete twice on the same memory region, which can lead to undefined behavior. In order to initialize a TrecPointer, you'll have to go through the TrecPointer key. If you're just creating a regular object or even a primitive type, then the getNewTrecPointer method should be sufficient. If you wish to create a subtype and have the counter held as a base type, use the getNewTrecPointerAlt method. If the base class happens to have a setSelf method, then you'll want to use these methods instead. Here is a list of some of the classes in Anagame that come with a setSelf method. The real point in having a setSelf method is that for the object to hold a soft pointer to itself. This leads to a brief discussion on the TrecSoftPointer. The TrecSoftPointer points to the same counter that the standard TrecPointer does, but does not increment the pointer. These types are meant to avoid circular references that can prevent the counter from reaching 0. Other TrecPointers offered include the TrecPointerSub and the TrecComPointer. The TrecComPointerSub is intended to hold a pointer of a subtype while pointing to a counter of its base class. If the object involved is an instance of the base class but not the subclass, the get method will return null. The get method is used to ensure that operations on the pointer will work. It's basically used for your null check. When switching between a standard TrecPointer and a TrecSoftPointer, you can use the TrecPointer key. The same is true for the TrecPointer and the TrecSubPointer. The real outlier is the TrecComPointer. These pointers point to COM objects provided by Microsoft and require special care in creating and deleting. Because they are created using factory methods and functions, the TrecComPointer comes with the TrecComHolder, with which you can initialize a COM object and then extract it into a TrecComPointer. If you wish to hold a COM object of a specific type in a TrecComPointer of a more base type, use the TrecPointer key. You also cannot switch between a TrecComPointer and a regular TrecPointer. This is because of how the objects are supposed to be deleted. A standard object held by a TrecPointer is supposed to be deleted the regular way. However, COM objects held by the TrecComPointer are supposed to have its release method called, rather than a call to delete. The TrecPointers were written so that there is one counter per object. This also means that TrecPointers should not be mixed with any smart pointers defined outside the Trec reference file, such as shared pointers or pointers from the Boost library. While using these pointers in isolation won't cause a pull request to be downright dismissed, I will develop a bias against that pull request, and if I see them mixed with TrecPointers, I will dismiss that request. There is more thorough documentation in the GitHub wiki as well as the Trec reference file itself.